See how you've done, all right? And so to find x, what is our formula that we're going to need to use to be able to find x? R cosine theta, yeah. R cosine theta. You could use delta too, not a big deal. All right, some variable, right? So we need to do R cosine. So cosine is what relates to x in our trig. And to find y, R sine of theta. Now we'll come back to slope here in a second. Let's handle these right now. And so if you handled this one here, you did x equals 2 cosine of 30. That would have been the x there. Over here, x would have been 3 cosine of 2 pi over 3. So if I did this one, what did you get for the x on that one right there? 1.73. All right, 1.73. The exact answer would have been square root of 3, but 1.73 is fine. Okay? Everybody okay there? On this one right here, I got, or what did you get, I should say? Negative 1.5. Anybody get negative 2 point something? All right. What did you have to do in your calculator to get from here to here? You got to change from degrees to radians, right? Got to switch. So negative 1.5 for that one. Very nice. And I think that's exact. That's approximate. That's all. Okay. If I go here, y equals 2 sine of 30. And then on this one, I'd go y equals 3 sine of 2 pi over 3. By the way, let me go back just real quick. I didn't address the last one. What would have been the x on this one? R cosine theta. Probably the easier of all of them because it's just a general term, just making sure that we understand kind of what's going on. Okay? All right. So what did you get for this y up here when you did 2 sine of 30? 1. The answer is 1. That's the exact, that's the approximate. It is exactly 1. Okay? And then on this one right here, we got what? 2.6. Okay, I think it was like 2.59 or something like that. Yep. So 2.6. If you did the exact version of that, you got 3 square roots of 3 over 2. Okay? You got 3 square roots of 3 over 2, which the approximate version of that would have been 2.6 or 2.59. Okay? I'll get you the other stuff here in a second. Grab that. We need that. Okay? And then if we go to the general form of this would be y equals r sine of theta. All right? Now, let's go talk about tangent. How do we find tangent? I told you I got ahead of myself. I'm thinking slope. Slope is tangent is what I'm going to do. All right? Now, question. Do I need an r in front of the tangent? No. Why not? They cancel. Because what we were doing the other day, we said tangent of theta is equal to sine over cosine. Correct? It's kind of how we started the other day when we were doing this. This would be r cosine theta, or r sine theta, r cosine theta, and the r's would cancel. So does it matter how big the circle is to tell me the slope of that line? It doesn't matter. Okay? So on this one, we won't need to find slope here. We can just use tangent of theta. We don't have to have an r there. Okay? Make sense?
What if I put the y over the x? Is that fine too?
If you put y over x, that's fine also. Now, could we have done that? Could we have just gone 1 over square root of 3? Or 1 over 1.73? Sure, that would have worked. That could have verified it. All right? And so, what is that slope? That's 0.577. Is that what you got? If you did it in exact terms, it'd be 1 over square root of 3 is what that would be. So that's my slope. What'd you get here? Negative what? 1.73. Okay, negative 1.73. Okay. And then we already talked about that, that's the, now, talk to me real quick. Where's this angle located? First quadrant. So X and Y are both positive, the slope is positive, all right? Where is this located? Quadrant 2, what happens in quadrant 2? The slope's negative because the X is negative. I got Y over X, so the Y is positive, X is negative, all right? This was a general format right here. What would you tell me about in this quadrant here? The slope is positive, yeah, because the X and Y are both negative, all right? So we got negative over negative, which turns it to positive. Slope would be positive. Okay, everybody okay with that? You want to be able to kind of do some of that. That's a lot of big stuff that we've been discussing lately. Should be pretty quick, easy there. All right, here's what I'd like for you to do next. Same thing, all right? We'll get to the front side of that page here in just a moment. I want you to go find me that missing side right there. I want you to do 2 of those real quick, all right? So I want you to go find me the missing side there. Use your calculator if you need to. Use your formula. All right, so let's talk real quick. If you know what you're doing, you probably already have it. You're done. If not, let's discuss. So what kind of triangles do I have here? I have right triangles. How are the sides connected in a right triangle? A squared plus B squared equals C squared. They are Pythagorean theorem. All right? So if I were to do that here, what's the most important part of Pythagorean theorem? What has to go where?
It all adds up to the hypotenuse.
C is your.
It all has up to hypotenuse. The C is the hypotenuse. That's the one that's got to be in the right spot. The other 2 doesn't matter. Okay? So the 5's got to go for C. So I'm going to go 3 squared plus x squared equals 5 squared. And so we have 9 plus x squared equals 25. We could subtract the 9. X squared equals 16 and x would equal to 4. Some of you might have looked at this and go, well, I knew that. That was a 3, 4, 5 triangle. I know that. Okay? But I can prove that with Pythagorean theorem. If I go over on this one, what's my C value? The x is this case. So 5 squared plus 9 squared equals x squared. So that gives me 25 plus 81 equals x squared. I believe that's 106. And I'll have to take the square root. I don't know the square root of 106. What's the square root of 100? 10. So it's going to be 10 point something or another. I can put in my calculator. I can go get that if I need to. Okay? Now, one of the things that we discussed in this unit is we talked about, and we saw this one day, I had you pick a lot of different angles and we plugged them in to prove that this is true. Right? What does that identity look like?
A squared plus B.
It looks like a squared plus b squared equals c squared if c is a what?
1.
Is 1 if it's a unit circle, right? And so if we were to look at this, this is like my 0, 0. This is the radius right here. I have a circle that goes like this, all right? So this 5 in this triangle is really representing the r value. It's really representing the radius. This is the x. That's the horizontal distance. That's x. This one right there is really representing the y, the vertical distance. All right? So if we were to rename these, x squared plus y squared equals r squared, is that really any different than that? Still the same thing, right? Still Pythagorean theorem. Now, previously on these questions here, if I asked you for x, what did you do? If I said go find x, what do you tell me? X equals what? R cosine of theta, correct? That's x. What's y? R sine of theta equals radius squared. I don't know what it is. Let's assume that it's not a unit circle. We don't know that for sure. So if I were to square this, I get r squared cosine squared plus r squared sine squared equals r squared. What's true about these two terms right there? They have anything in common?
They both have r squared.
They both have r squared. So if I factor out the r squared, that leaves me cosine squared theta plus sine squared theta equals radius squared. Anything else? The radiuses could cancel out. So in this form, it doesn't matter what the radiuses are? They really don't, because we got them to cancel. So now if I do that, cosine squared plus sine squared equals 1, which is that same thing. So I could prove that using my Pythagorean theorem. All right, as well. We did that a little bit earlier in the unit. Just kind of going back to it, just kind of showing that to you again. Okay, let's take and let's flip the page over now. Let's go to the review that I gave you on the way in. All right, let's see here. Got a picture of it. Mine's a little bit blurry, but I'm going to give you a little bit to look through some of those questions real quick, and then we're going to discuss them. So give you a little bit of time to look through that. Anybody else need one? Like, grab one on the way in? All right. All right, so what do you notice about these two triangles that I have up here? They are similar. We're going to come back to that here in a second. Good, they're similar. What else do we notice about them? They all have the same angles. What angle do they have? Particularly, they have a 90. All right, and so they're both right triangles. Could you find this value right here for that angle? How would you find the value for that angle right there? Add 90 and 34, then subtract that from 180, because we know they all have to add up to be 180. So going back to a little bit of geometry here. So I have to add up. Now, here's the other thing. If it's a right triangle, if that's 90, then what do the other twos have to add up to be? 90. What do we call that if two angles add up to be 90? Complementary angles. All right. So if they add 490, they are complementary angles. So add to 90. And so if I said 90 minus 34, then I could get 56. So I have that there. Okay. What if I did this? This is just kind of a little bonus one on here as I'm going. What if I gave you this, and I told you that was a 90, it's a right triangle. I told you that's theta. What would that angle right there be? 90 minus theta. Because they're complementary angles. So if this is 90, If that's a right angle, the other two add up to be 90. If I give you that one, then you could tell me the other one, it would be 90 minus theta. Everybody okay with that? That would be kind of the rule. So whatever I give you for that angle, we're just going to subtract that. Okay? So that's kind of what it means. That's where a complementary helps us in the triangles that we've been discussing. All right? Question 2. Triangles ABC and PQR, are they similar? How do you know? They're proportional. All right? They have the same angles. All right? What does it mean to be similar? What's kind of the definition of that? They could be dilated. They could change size, but they're not going to change the same shape. Same shape, but different size. So same shape, not necessarily same size. We knew that. Many of you said because it's got all the angles are the same. I guess not all the angles are equal, but they all have a matching one in the other one. Okay? So all the angles are the same. What would you call it if a triangle was the same size and the same shape? Identical. Okay? There's a fancy math term that we use for it. They are identical. Congruent. Okay? So if they're the same size and same shape, they are congruent. All right? But they're not in this case. Just kind of talk about the lingo. All right? Now, how would we determine the length of side AC? So how would we determine the length of side AC? So I'm going to go back up here. Here is side AC. Right there. If I look at what I have, I'm trying to find this. They gave me this angle, and they gave me this side. So we're going back and looking at a little bit of right triangle trig. All right, looking at SOHCAHTOA. All right, so if we do that, we're talking about SOHCAHTOA. I'm going to use sine if they give me the opposite and the hypotenuse. I'm going to use cosine if they're going to give me the adjacent and the hypotenuse, and I'm going to use tangent if they give me the opposite and adjacent. All right? So if I'm looking from the perspective of this angle right here, what two sides are we trying to compare? Opposite and adjacent. So that means I'm going to use tangent. Okay? So I'm going to go tangent of 34 degrees, and that would equal to 4 over x, because that's the opposite side is 4, and the adjacent side is x. Okay? Everybody okay with that? All right, give you a chance. You may not have looked at 4 and 5 yet. I'm going to give you a chance to look at 4 and 5. We'll talk about those here in just a second. What's the relationship between angle ABC and PQR? They are complementary. That's good. ABC is this one, and PQR is this one. So it's basically angle B and angle Q. So this one's 56, that one's 34. They add up to be 90. They are complementary angles. Very nice. Good. Everybody okay with that? What is the relationship between ABC and PRQ? They are congruent. All right? So they're using this same angle. It's the same angle there, but they said PRQ here, so we're using this one. So that one's 56, this one's 56. They are the same angle. They are congruent. All right? And then the last one on here says, how could you determine the length of the line PR? So I'm going to go back up here. Here is PR. I'm wanting to find that right there.
What do we use? Adjacent and hypotenuse.
Adjacent and hypotenuse. If I'm using adjacent and hypotenuse, then which angle are you going from the perspective of?
90 minus 34, 56.
Yeah, you're talking about 56, right? So she said if I'm using 56, then that's going to be on my adjacent side of my hypotenuse, which would be what? Cosine. So I could do cosine of 56 equals adjacent over hypotenuse. Perfect. Anybody else see it differently?
I did a sine of 34.
If I was looking from that perspective, from 34, then x would be the opposite side, so that would make that sine would be opposite over hypotenuse. So most likely, because I have the hypotenuse in there, I'm probably going to use either sine or cosine. Just depends on which perspective I'm looking for. Are both of those right?
Yes.
Yes. I'll take either of those, not a big deal. Okay? Now, I want to look at one other little aspect of this, and then we're going to look at your performance task. All right? If I were to, I'm going to redraw this triangle here. Okay? I'm going to redraw this one. What do you notice about in this triangle that they have the same or in common? What do these two triangles have the same, or what do they have in common? One of the sides is equal to 4. However, it's probably not the same side. If it was the same side, they would not be similar. They would be congruent. Okay? So if I were to redraw this, okay, I'm going to redraw this so that I have the 90 down in the corner like this one is. So that's P. All right? And I'm going to have the 34 down here. 34 is Q, so Q would be there. So that's 34, and that makes R up here. And then my hypotenuse is 4 on that one. Everybody okay with that? Now I can kind of see what I have. If I told you that in this problem right here, if I told you this was 5, could you tell me what this side is worth right there in the small one? Should be able to. How?
You could do 4 over x is equal to 5.
Okay. The hypotenuse compared to that side, so 4 over x, so that ratio right there should equal to the same thing as the hypotenuse over that same side there. Because they're similar, they ought to have the same kind of relationship, same proportions, and so I could set that up. Everybody okay with that? So I could go solve that. I could go tell you what that x is using that there. Other questions there? All right. So that'll be, you'll have a couple things like that. Got to kind of adjust and use those as you're going. They threw a little bit of geometry at us on this one. The first part of it, the front page, should be pretty straightforward. And then go from there. All right. What I want to do right now is I want to go over the performance task, all right, that I gave back to you. I want to walk you through that real quick.
Is the
That-
grade on our paper with a curve? Or is it not?
I'll explain here in a second. Yeah, and so I'll do that for you here in a second. And that way, if you do need a retest or anything like that, we can do that.